Hello and welcome to today's chemistry class for S.S.S.1. In today's class, we will be talking about the mole concept. But before we begin, let me tickle your fancy a bit. Life is a chemical reaction. It only requires balancing. This was given to us by the Indian Priyavrat Gupta. Going forward, let's look at the lesson objectives. At the end of this lesson, the students should be able to define a mole in terms of numbers, define a mole in terms of mass, define a mole in terms of volume. In chemistry, the term mole represents a pile or a mass of atoms, molecules, ions, or electrons. So now, for simple analogy, if I say give me a dozen of eggs, you are likely going to give me 12 eggs. But what if I say give me a dozen of beans? You can't, except you count 12 grains. But you see, the stress of counting grains of beans is so much. That is why we use measurements such as a bag of beans or a cup of beans. Same thing goes for rice. Because the grains are too small and too many, we can't sit down and start counting grain by grain. So we measure them with a quantity. We say 1 bag or 25 kg of rice. Same thing goes for maize. Because there are plenty, we are going to have to measure them using bag because we cannot count all the grains. They are too much. Now, this is the same thing that goes for an atom. Because the atoms are plenty, counting them will be too much. So we now use a measurement called the mole. So the same way you will say 1 dozen of eggs or 1 bag of rice, the same way we will say 1 mole of an atom. So going further about the mole. A mole is a unit which is used to express the amount of a substance. In other words, it is defined as the amount of substance which contains Avogadro's number of particles, and that is 6.022 times 10 to the power 23 particles. What this means is that if I say 1 mole of, let's say, hydrogen, I actually mean in that 1 mole of hydrogen, we have 6.022 times 10 to the power 23 particles of hydrogen. The unit of the mole is denoted as mole, M-O-L, while the amount of a substance, N, which is the mole now, is denoted, we calculate it by saying the mass of the substance in grams divided by the molar mass of the substance. Of course, the unit is mole. Let's now talk about the mole in terms of mass. The mole is the amount of substance, element or compound, which has a mass equal to its atomic mass. A good example, 1 mole of oxygen atoms is equal to 16 grams because the atomic mass of oxygen is 16. 1 mole of oxygen molecule, now don't forget oxygen molecule comes as O2, will now be 16 in 2 places, making it 32 grams. A third example, 1 mole of chlorine atoms will be 35.5 grams. That is the atomic mass of chlorine. But if we need the mass of one molecule of chlorine, don't forget a molecule is two or more atoms coming together. So chlorine normally comes as Cl2. That will be 35.5 times 2, making it 71. So the mass of chlorine molecule is 71 grams. The molecule in terms of number. 1 mole of a substance contains the Avogadro's number, 6.022 times 10 to the power 23 particles. So if you want a particular number, so okay, just like saying in that bag of rice, how many grains do we have? Same thing we are saying in that 1 mole of a substance, how many particles do we have? We are saying we have the Avogadro's number, 6.022 times 10 to the power 23 particles. In other words, 1 mole of hydrogen atom will contain 6.022 times 10 to the power 23 hydrogen atoms. Likewise, 1 mole of hydrogen molecule will contain the same 6.022 times 10 to the power 23 hydrogen molecules. 1 mole of oxygen will contain the same number, 6.022 times 10 to the power 23. 1 mole of carbon will contain the same Avogadro's number, 6.022 times 10 to the power 23, while 1 mole of water, H2O, will also contain 6.022 times 10 to the power 23. Why you are seeing this, in case you happen not to have understood this yet, if I say give me 1 dozen of biros, you will give me 12. If I say give me 1 dozen of eggs, you will give me 12. If I say give me 1 dozen of chairs, you will give me 12. So long as it is dozen, it will be 12. So if it is a mole, it will always be that Avogadro's number, 6.022 times 10 to the power 23. For emphasis, let's take some quick examples. How many particles are in 146 grams of HCl? Solution. If 1 mole of HCl will contain 6.022 times 10 to the power 23 particles. But don't forget that 1 mole of HCl has a mass of 1 plus 35.5. Don't forget, 1 is the mass for hydrogen, 35.5 is the mass for chlorine. If you add up the two, it will give us 36.5 grams. That is the mass of HCl. Now, that 36.5 grams has a total of 6.022 times 10 to the power 23 particles. This now means that if we take just 35 grams, that's the number of particles we have, the Avogadro's number. Then 146 grams will now contain X, an unknown number. If we now cross multiply and divide, we are going to have 146 times the Avogadro's number now, 6.02 times 10 to the power 23, which will now be equal to 36.5 times X, that unknown. X now becomes 146 times 6.022 times 10 to the power 23 divided by 36.5. This will give us a total number of 24.088 times 10 to the power 23 particles. So if 36.5 can have 6.022 times 10 to the power 23, 146 grams will have 24.088 times 10 to the power 23 particles. Let's now take a quick look at mole in terms of volume. 1 mole of a gas under standard temperature, which is 273 Kelvin, and pressure 1 atmosphere, will always occupy 22.4 dm cubed. A mole of gaseous substance can also be defined as the amount of substance that can occupy a volume of 22.4 dm cubed at standard temperature and pressure. That means 1 mole, of course we know is 6.022 times 10 to the power 23 particles, is equal to 1 mass, 1 gram of the molecular mass is also equal to 22.4 dm cubed at STP of a particular substance. Let's now illustrate this with an example. How many moles of oxygen are there in 11.2 dm cubed of the gas? Solution. 1 mole of oxygen has a volume of 22.4 dm cubed. X moles will have a volume of 11.2 dm cubed. You cross multiply and divide, you will have X times 22.4 equal to 11.2 times 1. If you press the calculator, you will see that X will be equal to 0.5 moles. Summary. In this lesson, we learnt about the mole as a unit of measurement, the mole in terms of mass, the mole in terms of volume, and we also took some examples. So, let's take some quick assessments. Question 1. Sodium combines with oxygen as follows: 4Na solid plus O2 gas to give us 2Na2O solid. What is the mass of oxygen needed to burn 4.6 grams of sodium? Question 2. The equation for the formation of water is 2H2 plus O2 to give us 2H2O. Calculate the number of moles of oxygen required to yield 6 moles of water. And so, dear students, with this, we have come to the end of today's class. Thanks for watching and hope to see you in the next lesson.